Now we know how to solve rational equations. Now we're going to apply rational equations. And what does that mean? Right, story problems, right? So this is the classic story problem. Mike can wash the car in 4 hours. Ray can wash the car in 3 hours. How long will it take them working together? I will give you the formula here, which is together over alone plus together over alone equals, do you remember? 1. Right, so if X is the time together, and if you think about it, if Mike can do the whole job in 4 hours, what fraction of the job does he do in 1 hour? Right, 1/4 of the job. So how much of the job does he do in X hours? Right, X/4 of the job. Similarly, if Ray can do the job in 3 hours, in 1 hour he does 1/3 of the job. So in X hours he does, right, X/3 of the job. And all together they do 1 job. The good news is this isn't too tough to solve, right? We just multiply everything by the LCD, which is 12. 7x is 12, 12 sevenths, right? But what is really 12 sevenths of an hour? Right? Well, you could say it's 1 5/7 of an hour, but how many minutes is 5/7 of an hour? How would we figure that out? Right, times it by 60, and 5/7 times 60 is about 43 minutes. So we would say 1 hour approximately, right? 1 hour, 43 minutes. Ta-da! The next one's another job problem, but it's a little bit different. Mary takes twice as long as Carol. So if Mary takes twice as long as Carol, how can we represent her time versus Carol's time? Right, Mary would be 2x and Carol would be x. Here we know the together. We know that the together is 4 hours. So we're going back to our equation, together over alone plus together over alone. So what's that? 4 over 2x plus 4 over x equals 1. And our LCD here would be, right, 2x. And we multiply that and we're going to get what? 4 plus 8, right, equals 2x. So x is going to be 6. And you got to be careful. You got to always make sure you answer the right question. It says, how long does it take Mary to do the job? So Mary's time is 2x, and 2 times 6 is 12 hours, right? So those are the job problems. This next one, number 3, is what I call a number problem. The numerator of a fraction is 4 more than twice the denominator. 4 more than twice the denominator. So if we make the denominator x, how can we represent the numerator? Right, 2x plus 4. So that's what we call the original fraction. Then it says if we subtract, if 2 is subtracted from the numerator and the denominator, that's going to give us a new fraction, right? 2x plus 2 over x minus 2. So that's the new fraction. And it said then the result is 8, or 8 over 1. How can we solve that? Our old friend, cross multiply, right? 8x minus 16 is 2x plus 2, so 6x is 18, so x is 3. But is that the final answer? It wants you to find the original fraction. So what do we do with the 3? Plug it in, right? 2 times 3 is 6, plus 4 is what? 10, and then 10/3. So that's our original fraction, 10/3. Good. Last one, rate times time equals distance. You remember this, right? What's this with the wind, against the wind? How does the wind impact a rate? If we're going with the wind, are we going faster or slower? Faster, right? And if we go against the wind, we go slower. So the rate's going to have like 2 components, right? Just a regular rate and then a wind speed. So let's see, let's start from the beginning. If the plane flies 1062 with the wind, is 1062, in the same time, it can fly 738 against the wind, right? And that would make sense that when you go with the wind, you're going a little bit farther, right? And then the rate of the plane, people get confused by in still air. In still air just means the regular rate of the plane. So sometimes I even cross that out. The rate of the plane is 200. Find the speed of the wind. So x is going to equal the wind speed. Okay, so if we said if you go with the wind, you go faster, isn't that 200 plus x? And against the wind slower, 200 minus x. Okay, so now we remember from algebra, of course, that rate times time equals distance, but we have this thing with the same time. So what is time equal to? Right, time is equal to distance divided by rate, and those two times are the same. So I can say the time with the wind, 200 plus x, is equal to the time against the wind, with time being distance divided by rate. And then how do we solve this? A fraction equals another fraction? Right, cross multiply, right? So if we cross multiply here, 1062 times 200, get some big numbers here, 400 minus 1062x equals 738 times 200, 600, plus 738x. So if we subtract here, minus 147. So I'm getting here 64,800 equals, if I add 1062 to both sides, 1800x. And then of course I'm going to divide. And that's going to give me my speed of the wind is 36 kilometers per hour. Right? We know that that's a little tougher one. You do have one like that on the test. It will be just like this with the same time, rate times time equals distance. So we have basically three versions of our problems. Either rate times time equals distance, a kind of number problem, and then a job problem. Applications of rational equations.